This is number 94 in chapter 8. It's a cumulative problem, and it reads that we need to use electron configurations to explain why copper is paramagnetic while its 1+ ion is not. And so basically we have, copper versus copper plus 1, and we find that copper by itself is paramagnetic, but copper plus 1 is not, and so it will be the opposite, which is diamagnetic. And so there's a difference in these electronic configurations in order for one to be paramagnetic and one to be diamagnetic. And so paramagnetic means that we have one or more electrons unpaired, and for diamagnetic means all electrons are paired. So that's the difference between the two. Paramagnetic, we have one of these guys at least that's not going to have a partner, while with diamagnetic, all of these guys are going to have a partner. So let's look at the copper neutral. Copper has the same electronic configuration as argon, and if we were just to look at the periodic table, we see we have this type of configuration. If we were to draw that out as orbitals, we have our 4s and our 3d, and we would fill these guys in appropriately. Now, copper is an exception to the rule here as far as filling in orbitals of lower energy before orbitals of higher energy. And so we have to remember with copper this is an exception because the highest level of the 3D, is pretty much almost at the same energy as that 4s. They're very, very, very close. And so remember, a D block is a set of degenerate orbitals, and if they are half filled or fully filled, you have a triplet state. And oftentimes elements will organize their electrons in order to have a triplet state. And so copper is one of those that actually prefers to not have its electronic configuration in this form, but to have its electronic configuration in this form. Where instead of having 2 electrons in the 4s, there's only 1 electron, and that electron has been bumped up to the 3d set. And now we have a triplet state. That is why the copper actually prefers to be not in 4s2 3d9. It actually prefers to be 4s1 3d10 as a result. So this is why it's paramagnetic. It's paramagnetic because we have 1 electron that is actually unpaired. You would come to that same realization if you had the other type of electronic configuration, but please remember this idea about the triplet state. So that explains why copper is paramagnetic, again because it has that 1 paired electron. So copper is paramagnetic because it has that 1 unpaired electron. Now let's look at copper plus 1. And we could go through the same argument, but remember that we're really starting with copper, which would have, again, argon, electronic configuration, and it would have 4s1 3d10. And so we're removing an electron, so it's really going to be 4s0 3d10. Again, it really wants to keep that triplet state with the D shell. And so we would have all those core electrons of argon. We would have the 4s, which would actually be empty now. We have the 3d, which is now completely filled, just like it was in the neutral copper form. Again, still has that triplet state. And so notice that all are paired, and so that's why it is diamagnetic, or simply not paramagnetic. So this whole idea of paramagnetism or diamagnetism is really dependent on the electrons and whether these electrons are all paired or not. For neutral copper, we have one unpaired electron, i.e. it's paramagnetic. With copper plus 1, all the electrons are paired up, and so it is not paramagnetic, it is diamagnetic. That is number 94.